Current frontier AI models require thousands of specialized GPUs running for months, burning through megawatts of power. These massive tech canvases are built on the premise that more data and more compute inevitably lead to better intelligence. But even the most advanced systems we interact with today remain highly sophisticated pattern matchers. If you change the rules of a task slightly, their performance degrades because they don't actually understand the causality of the data they process. Compare that to biology. The adult human brain operates on about 20 watts of power. Fueled by a few thousand calories, we can reason across entirely new domains, intuitively understand physics, and adapt to unfamiliar environments. Relying on brute force data centers creates a severe developmental bottleneck. When an AI requires massive, curated datasets and intensive human-guided fine-tuning just to perform a single specific task, it remains entirely dependent on pre-processed human knowledge. Achieving an adaptable, generalized intelligence requires a departure from the prevailing data compression model. It demands an architecture built from the ground up to mirror the extreme efficiency of biology. Jawed Tarifi spent nearly a decade at Google building some of their earliest generative systems, but he left the Silicon Valley ecosystem entirely to found a new company, Integral AI. Operating out of Tokyo, Integral AI has announced they have officially built the world's first AGI-capable model. The location was chosen deliberately. Japan leads the globe in advanced robotics. From day one, Integral AI designed their system not as a digital brain living on a server farm, but as an embodied intelligence meant to interact with real physics, real machines, and real consequences. By forcing their intelligence to operate inside heavy physical machinery, they move the conversation out of philosophical speculation and demand technical verification in the real world. To prove their claim, Integral AI laid out 3 specific, measurable developmental cornerstones. Pillar 1 is called autonomous skill learning. When presented with a completely unfamiliar domain, like operating a complex new robotic arm, the system must deduce the operational logic and teach itself how to function with 0 pre-existing datasets and 0 human supervision. Pillar 2 is safe and reliable mastery. In software, an AI hallucination means a wrong text answer. In the physical world, an AI learning through trial and error might unexpectedly drop a 100-ton crane payload. The learning process must happen without these catastrophic failures woven into its execution. The third requirement is the biological benchmark. The total energy cost for the system to learn and execute a new task must be roughly equal to, or lower than, the energy a human brain uses to learn that exact same skill. This chart shows the energy overhead of standard AI training compared to human biology. A typical massive language model consumes enough megawatts to power a small city. Integral's architecture drops down to human metabolic levels, around 20 watts. Achieving this efficiency requires an architecture designed for minimal power consumption from the ground up, creating a self-sufficient computational species. The engine driving this efficiency is abstraction-first learning. The system processes information into conceptual blueprints, focusing on structural relationships rather than raw data. By building a hierarchical model, it predicts events through physical cause and effect, rather than statistical correlation. This conceptual modeling directly addresses a major vulnerability in standard machine learning known as catastrophic forgetting. Historically, if you trained a neural network on one task and immediately shifted it to a completely new one, the new knowledge would overwrite and destroy its previous capabilities. Integral bypasses this flaw by mirroring the biological sleep cycle. The system performs what they call dreaming, internally simulating and consolidating new knowledge into its existing structure without requiring constant external data interaction. Integrating this seamless learning loop doesn't require thousands of GPUs spread across a warehouse. It happens within dense, specialized hardware units that connect directly to physical sensors. Leading AI research labs are actively validating this approach. DeepMind's leadership has recently pivoted away from pure reinforcement learning, stating that robust world models are the mandatory next step for intelligent systems. By mirroring the human neocortex, Integral AI is attempting to shift the AGI problem away from capital-intensive server farms and towards a model of stable, lifelong learning. If an AGI system can autonomously learn and operate heavy physical machinery today, the window for proactive global policy is closing rapidly. Independent scientific verification takes years. By the time the findings are published, the technology will already be integrated into physical infrastructure. This urgency has mobilized an informal coalition of researchers known as the AI Avengers. They are bypassing standard regulatory bodies and bringing the issue directly to the highest levels of global moral authority. They are urging Pope Leo XIV to launch a formal scientific consultation. The Pope is actively preparing a binding encyclical on AI, treating its deployment with the same rigorous assessment the Vatican applies to global climate change. The Vatican's diplomatic reach spans 1.4 billion people, operating independently of the nation-states and corporations currently competing for AI dominance. This allows them to act as a convening authority for global consensus that isn't tied to a specific national interest. When the Pontifical Academy of Sciences is engaged to draft global policy, it confirms that top researchers view AGI as an immediate challenge to human order. The prevailing approach to AI safety relies on complex filters and hard-coded instructions, but a system capable of out-reasoning its creators will eventually find a way to bypass static compliance rules. Integral AI proposes replacing those guardrails with the alignment economy. Their ethical framework anchors the AI to a single philosophical directive. Every action it takes must actively maximize human agency and possibility. They intend to execute this directive through the supernet. This is an interconnected ecosystem of embodied AGI agents serving as the operational backbone for civilization. These systems deploy autonomously to run factories, manage supply chains, and execute complex research, coordinating physical actions across the globe without step-by-step human management. It is a vision where a hyper-efficient, 20-watt nervous system assumes the burden of running human infrastructure. But if an intelligence explicitly designed to be better than us at everything takes over the physical management of our world, we have to answer a crucial question. Are we actually maximizing our freedom, or have we permanently surrendered our agency?